All right, Algebra 2 notes, 8.2, exponential decay. So as we go through today, all of the stuff we do is going to look very similar to what we did last time. We're just going to change one thing. Instead of exponential growth, where it's increasing, we're going to have exponential decay, which means it is decreasing. So our learning target. I can identify exponential decay situations and model them with an equation. So as we go through today, we're going to do some different situations, the opposite of what we did last time. So, first example, counting chips. So I'm going to start out, and I'm going to have a bag of 100 of these counting chips. So we've been given some counting chips. Count the total number you have and record it next to trial 0. So we have 100 chips. Go ahead and write that in your table. Now, it says put all the chips back in the bag, mix them up. Mix them all up and pour them out. Okay, spread them out. And we want to know how many of them are yellow side up. So I'm going to go through and I'm going to sort them. All the reds on one side, all the yellows on the other. Whichever side is face up. Oh, I flipped that one. Alright, get them all sorted here. Alright, so I got my yellow section and my red section. So it says, pick up all the chips that have the yellow side facing up. So that's these. Count them and record it next to trial number 1. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49 total. Alright, so I'm going to record that next to trial number 1. 49. Okay, put only the yellow side up ones back in the bag. So I'm going to get rid of all the ones that were red. Move these off to the side. We are not going to use those anymore. Alright, and I'm going to put all my yellow ones back in the bag. Alright, shake them all up. And pour them back out. Okay, spread them all out. And I'm going to sort them. Alright, so we're going to get rid of the red ones. Red ones go away. And we're going to count the yellow. 3, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So I'm going to put a 19 next to that one. Okay, put all these back in. Okay, separate them out again. Okay, so I'm going to get rid of all the red ones. I have 6 yellow ones left. Okay, put them all back in. Oh, one fell on the floor. Alright, now I only got 2 yellow ones left. Hopefully that wasn't too loud. Alright. 1 of each. So I only got 1 yellow one left. Oh, red. Now I got 0. Alright, so let's plot these points. 0, 100. And I think it says to do it in pencil. So I'm going to switch over. And I'm going to do this in pencil. Zero, 100. Alright. 149. So that's just less than 50. 219. So I'm going to go 2, just less than 20. 3, 6. 4, 2. 5, 1. Alright. So how many chips were there in the beginning? Well, you can see right here, there were 100. How quickly were we using chips? Losing chips. So we went from 100 to 49. And then 49 kept going down, 2 to 1. So we lost about half. How long before all the chips were gone? 6. So you can see right here, it is trial 6, where all the chips were gone. So I went ahead and I plotted my points. Now I'm going to connect them. Sketch a curve. It's kind of hard to make this line here. That's how we did this one with pencil. Well, they kind of work. We kind of get the idea there. And the question asks, do the points fit perfectly on a curve? No, they're not perfect. Okay, so let's see a little bit about how we're going to use what we did last class with the stuff we're doing today. So we have 2 formulas for decay, just like we had 2 formulas for growth. Just like before, A is our starting amount. In both examples. Okay. B is going to be our decay factor. So before, it was 2 if it was doubles, or 3 if it was triples. Now, we are going to have our decay factor be something that is less than 1. So some fraction or decimal that is less than 1. Over here, our percent is going to be a percent decrease, but we still have to write it as a decimal. And x is still our number of times. So, in a perfect world, if we go back and do that last situation, find the A and B values for the CHIPS problem. So, A is our starting amount. How many did we start out with? 100. So 100 also goes over in our formula there. All right, our B value. How much were we losing each time? We were losing about half. So you can either write it as half, or you can write it as 0.5. Either way, I'm going to write it as 1/2. So this right here is my exponential function. All right, so let's graph this function on your calculator. Use the table feature to find points. So on your calculator, home screen, new documents, don't save, add a graph. Okay, and we're going to type this in. 100 times, I'm going to put in my fraction, 1/2, close your parentheses, to the x power. So you can kind of see that curve, like what we had last class, but this time it's going the other way. So we're going to do Control T, and we're going to find those points, and we're going to go back to this previous page here, and we're going to graph it in pen and compare it to those. So Control T. All right, so I have the point 0, 100. Okay, that was the same in both. 1 should be 50, so we were just a little bit off. 2 should be 25. 3 should be 12.5. 4 should be 6.25. 5 should be at 3. 6, 1.5. 7, oh, we're getting down there. 8.3. 9.1. 0.09. Man, we're getting lower and lower. All right, so let's sketch a curve through these. Hopefully you can draw a better line than I can. Did our two lines match up? They were close, but not perfect. All right, so right now you have 3 questions here. So I want the sub to pause the video, and I want you to go through and I want you to answer these questions, talking only to the people in your groups, not getting up and moving, only talking to the people in your groups. So go ahead and pause the video now and get these done. Once everybody's done, you can hit play again. All right, let's see how they went. Let's talk about them together. Do the points fit perfectly on the curve? Those points, those pink points, fit perfectly on an exponential curve. We didn't have any points that were off the curve like we did here or anything. So, did they fit perfectly on the curve? Yes. And then how do they compare? Do they match up perfectly? Why or why not? So the pink line cut in half every time. Exactly. But when we did our actual trial, when we went from 100 to 49, did that get cut perfectly in half? Or 49 to 19, was that perfectly in half? No, it wasn't. So, they did not match up perfectly. So the actual data wasn't exactly half. All right, then it says calculate how long it will take in this perfect world to get down to exactly 0. So I'm going to go back to my calculator here. When do I get to exactly 0? We're getting smaller, we're getting smaller. Now, remember, this notation, that E, means that it's a really, really small number. So that means we're going to have 0.00000. We're going to have 10 zeros before we get to 3. That's what this means. So keep going, keep going, keep going. I'm sure some of you can scroll faster than I can. When are we going to get to absolutely 0? Alright, I got 45 decimal points. I'm still going. When am I going to get to 0? So think about that piece of paper activity that I demonstrated for you last class. So I took the piece of paper and I ripped it in half. And then I took that half and I ripped it in half again. And I took that half and I ripped it in half again. When did I get down to 0? Well, you don't. So how long will it take to get this perfect world to get down to exactly 0? Never. Because technically, there will always be a half. Now, you can think about it this way too. We can't have half of one of these chips. It's either the whole chip or half chip. So you can also think about it that way in that, well, kind of, you'd never get decimals, but you could essentially cut it in half and get rid of half, and then cut that in half and get rid of more, and cut that in half, and so on. Alright, so as we go through these next few problems, these are going to look very, very similar to what we did last time. The part that changed is that instead of a plus here, now we've got a minus. Alright, so I'm going to go through, and just like what is written on the board, I'm going to do my starting amount in pink, and my growth factor or percent, or my decay factor or percent in blue. Suppose car is worth $30,000. The car's value decreases by 17% each year. Write an exponential function to represent this situation. Alright, 30,000. That's how much we start out with. So I plug it in here, and then into my formula. Alright. The car's value decreases by 17% each year. So 17%. But I can't leave it as a percent, because what do we say we have to do to percents up here? We had to have them as a decimal. So I need to take this decimal point, I need to move it over 2. So that's actually going to be 0.17. 0.17 is what I'm plugging in here. That's my exponential function. So I need to find the value of the car in 5 and 10 years. Alright, so I'm going to go back to my calculator, and I want to add a calculator feature. So I'm going to do Control Dock, and I'm going to add a calculator. And I'm going to type this in. 30,000 times 1 minus 0.17, close my parentheses, to the power. Now what is it actually asking for here? Well, it's asking for two things. I need the value in 5 years and again in 10 years. So the first time I go through, 30,000 times 1 minus 0.17 to the 5th power. So I'm going to type in a 5. So after 5 years, it's worth $11,817.10. Okay, now I'm going to take the same thing, 30,000 times 1 minus 0.17 to the 10th power. So I just need to take the same thing and change that 5 to a 10. So I'm going to copy it, up, enter, and I am going to change that 5 to a 10. So that gives me $4,654.81. All right. With your partner, I want you to try example 3. See if you can do part A and then do part B. So go ahead and pause the video and try part A. All right, let's check and see how we did on part A. So my A value, starting amount. Man, I got a lot of numbers here. I have 11, I have 7, I have 128, and I have 869. So the starting value is this dollar amount over here because we're talking about its value. So my A is $869. Okay, it is losing 11% each year. So that is my percent. Change that to a decimal. So we get 0.11. How'd you do on that part? Okay, if you need more time for B, go ahead and pause the video here and then see if you can do part B on your own. Alright, so this time it gave us 3 things for B. 2 months, a year, and 3 years. So for 2 months, I'm going to use x equals 2. So I'm going to take my function, and I'm going to do my exponent of 2. So after 2 months, it's only worth $688. And 34 cents, something like that. All right, what about a year? What am I going to use for my exponent? So if it's after so many months, a year is going to be x equals 12. So same thing, but now my exponent is 12. So I'm going to do up, enter, I'm going to copy it, and I'm actually just going to add a 1 in front of that too, to make my new exponent be 12. $200, man. Cell phones aren't worth much, huh? Alright, and after 3 years. So 3 years times 12 months in a year. I needed an exponent of 36. Okay, so I'm going to do up, up, and then I got to do it again so I can get back to that. I'm going to copy that, and I'm going to delete my exponent and change my exponent to 36. Wow, awesome. $13. And 9 cents. Alright, so when we go to do the next page here, one more page of notes, we are going to first talk about an asymptote again. So, same definition as before. An asymptote is a line that a function approaches oops, I spelled that one wrong. But never touches. So when we look at this example, our asymptote is this axis line right here. So we mean that that asymptote right there is the line y equals 0. It's never actually going to get, this function looks like it gets down there, but just like what our table showed us in here, it's going to keep getting closer and closer. It's going to essentially be 0. So now we've got 74 zeros after the decimal point, and then we get the number. So it's getting itty bitty, but it's still not exactly 0. Alright, domain. Domain is our x, it's our left, and our right. So notice its angle. It's going to keep going angled to the left forever, and this arrow goes to the right forever. So it is that wonderful symbol. That means all real numbers. Range is our y. It's our up and down. So does this go up and down forever? Well, just like before, we get to this asymptote and we never actually get to 0. We go up forever, but we can't go down forever. It doesn't ever go to these negative numbers. So it's going to be y is greater than 0, because from 0 it goes up. Alright, example 6. Example 6 is the same as what we did last class. The only thing that's different is that this time our b value is going to be something less than 1. So I want you to go ahead. Here are your 3 points. I want you to write in what goes here. See if you can get a and b, and then plug it into your function, and then use it to predict. Go ahead and pause the video here and do that math. Alright, let's see what we did. So my first point is the point 0, 600. So I'm going to put a 0 in my x list and a 600 in my y list. The next point, 1, 420. 1 in the x list, 420 in the y list. And 2, 294. So I'm going to put a 2 in the x list, a 294 in the y list. Alright, go through on your calculator. I believe this is a calculator tab. Yep. So I've got a calculator page open. Menu. 6. 1. And then remember, the thing that's different this unit is that we aren't doing 616. We're doing 61a because these are exponential curves. Okay. First thing are these wonderful, wonderful squiggly brackets. They're actually called braces, so make sure you put your braces in first. Control, close parentheses, 0, 1, 2. And for our y list, same thing. Put in those squiggly braces first. 600, comma, 420, comma, 294. Hit enter a couple times, and we get that. So this tells me that my A value, or my starting amount, is 600. Well, yeah, that makes sense. At time 0, there was 600. And it tells me that my B value is 0.7. So we said our B value this time has to be less than 1. Some fraction or decimal less than 1. Well, 0.7 is less than 1. Alright, so I'm going to write it as a function. F of x equals A, which was 600, times B, which is 0.7, to the x power. Okay, got my function. Now, use your function to predict the population after 8 hours. So now we're going to use 8 as our exponent. 600 times 0.7 to the 8th power. So get this typed in your calculator. 600 times 0.7 to the 8th power. Don't shout it out. Give people a chance to type it in. So I'm going to round this, so I'm going to use my approximately sign. Approximately 34.588. You could leave it at 34. You could do 34.588. And what are we in here? Bacteria. Yuck. Alright, we got one more example. For now, I want you to ignore the multiple choice. And I want you to try and do this part on your own. So, with your partner again, I want you to fill out this part over here. Go ahead and pause the video. Alright, let's see how we did. Our starting amount, the height of the tallest water slide in the world, is 417 feet. 417. That is my A. That is how high we start on our water slide. It can only decrease at a rate of 3.75%. So think about a water slide. If this is our water slide, they can start off really steep, but then they've got a curve, and don't they have a long flat part at the end so that you don't get hurt? That's the idea with this problem. So 3.75%, but we need to convert that to decimal. Move your decimal over twice. 0.0375. Alright, so matching up with our multiple choice, they all start with 417. Uh-oh, none of these match. Okay, so here's what we need to do. We need to take this, and we need to do that math. So, 1 minus 0.0375. Go ahead and type it down in your calculator, see what you get, and see if it matches. 0.9625. So that is what goes inside the parentheses. I still have the x on the outside. I still have the 417 out in front. So now that matches this one. It's actually a parentheses. It didn't copy very well. There's you can kind of see it there. These were both supposed to be M's in parentheses. I don't know why they put them in parentheses. This is an EOC question. So there we go. Alright. So I want you to pause the video here. You're going to work on your assignment. Your assignment, just like last class, has a lot of explaining. So make sure after you do a question and you answer it and you say, okay, which one is not true? Well, it's this one. Then you go and explain. When it asks you to explain things, you go through and explain. So you've got 2 pages today. You have page 11 and page 12. So there's 4 problems and then some explanation stuff to work through. Go ahead and work on that. And then in about 10 minutes, if the sub would restart this video, so you're going to hit pause here in just a minute, and I will go over Cornell notes in about 10 minutes. All right, Cornell notes time. So we are on page 5. So make sure you are on page 5 if you are not there already. Get to page 5. We're going to go ahead and do these notes here. So our quality question, where does exponential decay show up in the real world? So you need to come up with 2 examples, not already in your packet, and explain them. So all of your examples need to have a starting amount and a growth factor. So let me give you an example. If you look back at our notes, we got rid of half of the chips every time. We started with 100, got rid of half. A car's value, we had a starting amount and it decreased by 1%. A cell phone, we had a starting amount and it decreased by 1%. Bacteria, we had a starting amount and it decreased by, this time it was a decimal. You could do that. And here we had a water slide that decreased also. So you need to come up with 2 examples. So what I want you to do in your Cornell notes is split, after you write your question, split the rest of it in half. And I want you to write 2 examples of how you see exponential decay in the real world. I also want you to go through on each example after you've written it, and I want you to find your starting amount, whatever that starting amount is. And if you have highlighters, you can highlight it in pink, or, like what's written on the board, put a box around your starting amount. And then your decay factor, or percent, I want you to circle it, or highlight it in blue. So if you have highlighters of these 2 colors or pins of these 2 colors, you can do that. Or you can just box this in and circle this in. This is what I'm going to be checking for this. Do that for both examples. So they should both have a starting amount and they should both have a decay factor. All right, so our summary. For this summary, I really want to compare growth and decay. So I'm going to write out the growth formula first. And the decay formula down here. So growth, f of x equals a times b to the x. Or the percent one, f of x equals a times 1 plus the percent to the x power. Decay. Well, the decay factor looks exactly the same for both. So how do you know which is which? Let's go ahead and write the second one, then we'll talk about it. The decay factor with a percent, the only thing that changes is it's now 1 minus the percent to the x power. So let's look at the differences. So this one's easy to see. We got a plus there and a minus there. So there's one way you can tell the difference between growth and decay. But what about this one? This is a B and this is a B. How do we know if it's growth or decay? Well, if it's going to get bigger, you're going to have to multiply it by something bigger than 1. So my b value for growth has to be greater than 1. And if it's decay, if it's getting smaller, it needs to be something less than 1. And we actually can't have negatives, so I'm actually going to put that on the other side. So this has to be some fraction or decimal between 0 and 1. All right, and for your questions column. Questions column. So let's make one of our questions be, what is the difference between exponential growth and decay? So go ahead and write that over here in your questions column. What is the difference between exponential growth and exponential decay? So you can talk about the b value or about with the percent, how it changes. And then the other one I want to make sure you have, how do you convert a percent to a decimal? How do you convert a percent to a decimal? All right, that is it for our exponential unit. So this packet is hopefully going to get done today in class. So you can turn in your packet if you would like. I will be back later to pick them up. Please make sure you fill out all the stuff up here at the top. If you need one more day to finish anything up, you can take it home, bring it back. But once you're done with it, go ahead and turn it in. Can you believe it? Fastest packet ever, right? All right.